What's up, what's up? Welcome back. Today we're working on my terminal emulator. His name is Termi. We've been at this for about like 3 weeks now, and we're in like a pretty reasonable spot. So we have like this terminal emulator. I can like increase the font size. We can like visualize like what's being displayed, and we can do something like git log, and we have like, you know, something here. If I resize, like the content resizes, and I hit like down, down, down scroll, we're seeing like we're seeing like yellow text, red text, green text. You know, things are like kind of working. But we're in a kind of a state where less, the like pager here, is not working correctly when it has long lines to wrap. So let me see if we can find an example. If I scroll down, and if I scroll down here, what's going to happen is what should be rendered on like this bottom line here is going to like replace the start of the line. Yeah. And so we're trying to figure out why the fuck does that happen? We don't understand. And we like recorded we like looked at like the output that Les is giving us. He's saying stuff like, hey, I'm going to like clear this line, and then I'm going to like navigate, move the cursor over here. I'm going to like put out this text. And what it was like trying to do did not line up with my understanding of like anything. And so what we're kind of working on is we're trying to figure out how can we like debug this type of problem better, right? And so we're working on a replay system, because the way that the code works right now is we have like the data class slash the guy who does all the real work. He's called terminal emulator. We'll just Termi. We'll write Termi like this. And he asks Linux to like spawn a shell, and he communicates with that shell through like a file descriptor. So like basically all commands, well, not all, but the vast majority of commands, like things like please move the cursor to this position, those kind of come in from like bash. Bash will live somewhere else. Bash, or, you know, whatever program. He's going to be like on the other end of this pipe, right? And so bash is going to say, like, we might like say like we press the letter A, that gets sent to bash. Bash says like please send the letter A back, and then we like display it in our like little data buffer. So this guy's got like a buffer that he's like keeping track of state in, and he's like putting the A in here. And what happens is bash might send like hundreds of characters at once, right? He might send like just like a large string here, and we're gonna just update this buffer with like as much as we can consume from the file descriptor right now. So what happens there is we have like this GUI now, this GUI area, and he's gonna talk to this guy and say like, hey, can you show me on each frame that I'm trying to render, can you just like tell me what I should be displaying? And so the terminal emulator class is gonna like say like, okay, well here's the visual area, and like here's the scroll back. And like there's like a bunch of like associated information, like coloring information, should it be bold, blah, blah, blah. But the problem here is if we want to see character by character what happened, like what the fuck bash was trying to do and why we're not displaying it correctly, we kind of want like more granularity than this. We want to see, okay, let me like see what happened over time, and let me kind of like look at those states individually, right? So I might want to see like in my program, I want to see like, so he sent like the cursor was here, and then he said move the cursor, and so like where do I put the cursor after he moves it? Well, he said move to the end of the line, so I'm gonna move to the end of the line. I kind of want to like see what that looks like step by step, and then maybe by doing that we can build some sort of intuition on like what's going on under the hood. Yeah, so that's what we're working on. And last stream we like came up with like a recording system. So let's see, if we cargo run, I probably could have shown it here. We can like get into some bad state, right? So we can find, okay, here's an example right here. So we can scroll down, and so maybe we just start recording and we say down, down, stop recording. Like we reproduce like the problem there. And then we can go into our like recordings, and we see, okay, so here is the state that our process was in when we started. Like here's like the current scroll back and buffer. Here's like our formatting info. Here's like here's like our parser state. And then he says, okay, now after that, here's like what happened. Here's a list of things that happened after that state. And so what we want to do now is we want to like load this recording back. We did like a proof of concept loading last stream. But we want to do something like a little bit more complex now, where we like load this back, inject it into the terminal emulator, and maybe have like a little timeline on the side or at the bottom where we can like scroll through events that happened, look at things character by character. That's what I want to look at. And so the plan of action there is one is we have to remove this assumption. This assumption from like the terminal emulator. So right now the terminal emulator class assumes that he's talking to a shell. And so we need to like abstract that concept away and say, okay, you might be getting your data from like a shell, or you might be getting it from like a recording that we've loaded. So that's like step one. Step two is to implement control of the new interface, right? So we're gonna maybe like split this out and say like, this guy is going to be abstracted by like term IO, right? And so we have this guy, and we're going to have one that's backed by like replay. And this guy is going to like implement all of the same interfaces to like read and write data. But we're going to want to say we need like some like external handle to this guy that will connect to the GUI that can say like, what do I do when I want to like, like in the GUI, I'm going to like say, go to this position. And so this guy is going to have to control this guy to say like, okay, you're allowed to emit more data now, essentially. So we're gonna have to implement this like replay class here. Then we're gonna have to like add like some like a v1 GUI, which I'll probably just be like a slider on the bottom. And then like something that's more advanced that shows like every character and lets us like inspect state a little bit more in depth. That's the plan. So first thing to do is update terminal emulator to all different sources. Okay. So what I'm thinking is right now this guy has like that assumption that we're like working with this file descriptor that talks to bash. And I think we can just kind of do something like, let's say in terminal emulator, we're going to have like an IO section. So like make dir IO. And in here, we're going to touch mod rs. In here, we're going to say mod IO, A, B, C, D, E, F, G, H, I, J, K, L, M, N, P. Yeah, okay. I probably could have just done sort, but I sometimes like to say the whole alphabet for fun. It's a fun thing to do. Okay, in our IO section, we're gonna have like a trait that we're gonna implement, and I've actually managed to write a lot of Rust code without having to deal with interfaces. Like a lot. Like it's pretty rare actually that it comes up. I feel like when I write like C++, I'm putting interfaces all over the place. Maybe that's just like the nature of the C++ applications that I've worked with. But I find that like Rust enums kind of like solve a lot of the cases that I needed that for anyways. But so I'm a little shaky on the syntax. But I think it's something like term IO, we'll call it, right? I don't know if you need to put the pub here, but probably do. And I think you need to like define some functions. So we're gonna have to look at whatever our terminal emulator does right now with this file descriptor, and we can just make functions for all those things. So one is he sets the window size, one is that he writes data, and one is that he reads data. Easy. So we just have read. So, oopsies. Let's maybe look at the interface for these things. So read. He's basically feeding him a vector, and I guess probably as a slice, and he is returning how much he read. Okay, sure. So we're gonna have read. He's gonna take in self, and probably by immutable reference. And we're gonna take a buffer, which is a mutable U8 slice. And we're gonna return a result usize. And probably some sort of error, but we'll maybe allow users to define the error type, so that, it can be different for different interfaces. I actually don't know if this works well for like dynamic usage of these things, but we'll find out. Then we are going to need a write call, which is just going to take in mutable self and a buffer that he's going to try to write to the terminal with. And this guy he is going to return the number of bytes written. Okay. And the last thing was set win size, I think. which is here, right? So set window size just takes the width and the height. New self width height. Okay, easy. Easy. Sure. Okay, so now what else are we gonna have to do with this guy? We're going to take all of the implementations of these things in the current terminal emulator and replace them with this guy. So first, I guess we'll make a struct. And I'll probably want this in its own file. So we'll call this, what do I call this? pty.io. Maybe I'll just call it pty.rs. Cool. And here we can say mod pty. And pub use pty.io or something. And we'll say struct pty.io. Boom, boom. Make them public. And we'll use super term.io. And we have to implement this interface now. So he's going to have this stuff that was previously owned by this guy, and we'll implement missing members, boom. And I guess we'll just start moving. So this function will no longer live here. This stuff all lives. All of this lives in this file now. Which means we're probably gonna have to copy paste the imports. And somebody will tell us that these are unused, and that's fine, but we'll just copy paste them all for now. So this guy has this like set window size free function that takes in file descriptor width and height. We can probably just put this guy directly in the implementation here. Okay. Yep. And instead of using FD here, he's going to use self FD. He's going to... he needs to return an error, so this term IO thing needs to return an error here as well, which I guess is just result nothing self error type. Okay. So now this guy can return result nothing self error. Okay. Cool. We need to provide the error type, so I guess we have... we need to just define a new error. So before we were using set window size error, but I guess if we're using the same error for all of these, we could do something like... we'll call this guy pty error, pty.io error. Okay. And this guy's gonna say type error is equal to pty.io error. Yep. And sure. Yeah, we'll figure it out. Figure it out as we go. Okay, so the terminal emulator now. We need to look at the read and write calls. So function read. This just does what? He has a buffer that he's trying to read from. And I guess it's just this that gets abstracted out. Maybe even just this. Because both interfaces are going to have to loop in the case where, like, they're going to have to loop till we fail, essentially. In both cases. So I think it's literally just this. Which is nice for me. Okay. So we just do this. Boom. Mismatching error type. So he expects a pty.io error, which means this guy is going to have to support more things. More things. So we can say what? We need our error type to be some sort of like error kind, and this is going to be an enum here, and he can be derived, he can come from set win size error. I don't know if this is like the cleanest way to do this. I'm just doing like whatever like is in front of me is what I'm going to write. Failed to set win size. Sorry, my dog's like playing with a ball under my desk, and so I keep like having to check to make sure it's not going into wires and shit. Okay, and then the other type of failure is like read. And this is going to come from whatever this guy returns. Which is a Erno. And I guess it won't be like autocast. We'll say from Erno. Okay. And we'll say error failed to read from file descriptor. And he will have like a little backtrace as to why. And presumably we're going to have another one from write. Failed to write to file descriptor. Okay. And so now this guy comes from p2i.io error. p2i.io error kind. Cool. Cool. And so then these guys have to do like a little map error into or something. I don't know. Does that work? Yeah, it looks like it does. Map error into like this. Boom, boom, boom. Okay, because they're like double wrapped, which is a little annoying, but we'll live. Oh, they don't actually like that. So instead we'll call this p2i error kind set win size. There we go. That should be clear. For the type system. Okay. Cool. So this guy gets mapped to p2i.io error kind read. Okay, and we need to do a little type coercion. Can't mutate immutable variable buff, so this guy gets passed in as like this. Chillin'. And now we have to do the same for write. So let's look at function write. And this is just like this. Boom, 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 boom. Self fd as raw fd. This is the buffer. And we return this as like this, okay, like this, and we have to map the error. p2i IO error kind right. All right, everyone's happy. So I think theoretically we should be able to just swap this guy out now. So we should be able to say terminal emulator has IO of box dyn term IO. And I'm doing this on purpose, using some like indirection here. Hold on. Is this not the right syntax? Oh, we need to specify the arrow type. Oh, what a pain in my ass. Okay, hold on. But to finish that thought, the reason we're doing the indirection here is because, you know, you could put this here as like IO is term IO and then put this guy here directly inside. But that just means like the replay and like bash types of these terminal emulators will have like different types, and that will make it like complex for usage a layer up. So I'm just gonna take the hit on indirection here and just be okay with it. Okay, let's go back here and say that the error type has to be the same for all of these guys. So we're just gonna say pub struct term IO error, okay? And I think we're gonna do some sort of like error transparent as well. So we're gonna have like some sort of like error kind. This, and this will be like this. And then we say term IO error kind like this. And the reason to do this is because like it like makes like API boundaries on your errors, so you don't like you can still provide this like backtrace of this guy contained this guy, and so like this was caused by this, caused by that. But the users of this guy can't like depend on the inner details of your error type essentially. So we're gonna say use this error which I use because it's very close to what I would write by hand, and writing it by hand is a piece of shit. It takes so fucking long, so that's why I do it that way. And then these guys are all going to return term IO error. Like this. Boom, boom, boom. Okay. And that removes like the generic from this guy. Okay, but that means that all of the guys in PTY now have to let's see. So we could use some sort of indirection here so that each version of these guys can define their own error types. That seems kind of reasonable. So can we do like box error? Do we just want to do this? That way, implementers can define their own like complex error types and not worry about it. Sure. And then here we just write from, I guess. And I think we're chilling. Yeah. So now we can say this is a term IO error. And then you're asking like, well, why don't you just return a generic error type here? And I'm like, yeah, I guess we could. And maybe that is the right call here. We just say all of these guys return box error, which is fine. So we could say like pub type term IO error is equal to box dyn stood error. And yeah, fuck it, I'm okay with that. Reduce the complexity a little bit. Okay. So now these guys need to use super term IO error. This. And does everything just work now? No. No, it does not. Because in the terminal emulator mod, we deleted the file descriptor. And we need to replace everything that we used to use it with the new term IO thing. So for now, we'll hard code it as pty IO use, and we are just going to construct a new one. Okay. Which means that this guy needs to have some sort of function to create one. Right, pub function new, and he returns a pty IO. Nuh-uh. Ginger, no. Sorry, dog. That way, please. Okay. And so he does... Good girl. He's going to have to do all of this stuff to construct the file descriptor. So these functions... There we spawn the shell and create our term info stuff and set non-block. This is all like IO specific stuff, so these guys can live here as well. Okay. Yup, makes sense. Which means that these guys now will live in here, and so we'll say this is how we construct these things. So where's our function new in here? Boom. Which means that this guy needs file descriptor and term info dir, which is a term info dir. This guy can return a result, and we'll say create pty IO error. Okay. Cool. There's a lot of problems that have been caused by this, but we'll kind of clean them up as we go. Okay. This calls set window size. So instead of doing this, we'll call io.set window size like this. Okay. And now we need to pass in the IO, which means that this guy actually has to be boxed. He needs to be a pointer, and I'm missing a type parameter for some reason. Where? Create terminal emulator error kind. So I guess this will come over here and be called what did we call it? Something PTY error, create PTY IO error. Create PTY IO error kind. Yep. And then this guy is the same, but instead of terminal emulator, it's PTY IO. Okay. We're getting close. We're getting close. Now this on like the external interface is not going to have these like specific things. He's going to say create PTY is like the only way he can fail. So maybe for now we'll just change this type to create PTY IO error like this, and then we have to use that guy. So where's IO in here? IO term PTY IO PTY create PTY IO error. Which means probably in this like IO mod, we have to publicly use that guy. So here we need to say create PTY IO error, boom, boom, boom. Okay. That's a lot down. No method named set window size on this guy. That's surprising to me. Oh, because it's called set win size, not set window size. And this guy needs to be mutable, boom. Okay. And you might be missing a type parameter. Okay, cargo, check. What's he complaining about? Doesn't have a size known at compile time. Why is it complaining about that? Size is not implemented for dyne stood error. Sure, of course. But, oh, because this backtrace error, it takes an error E. And no, I don't see a problem with this. Do I have to put E here? Consider borrowing. Okay. E is equal to, do I have to like, can I do like E as ref? Like, no, I don't understand. I'll have to come back to this. I'll come back to it. What else is it complaining about? Something about like missing type parameter. I don't understand this. Unresolved import ANSI? Oh, sure. So these guys all have to be coming from crate. Terminal emulator, like this. Okay, unresolved import of format trackers. This is again, these are just don't get publicly used. This isn't used. Crate, terminal emulator recording. Like, I think a lot of this stuff just isn't used at all, but you know, we're living with it. Term info needs to be moved from terminal emulator. So here we had some const term info. We just yoink this guy and put him here. And his location is going to be different relative to this file, but it's okay. We're using absolute paths here, so we're not in trouble. Undeclared error create terminal emulator kind. Because these all have to be create PTY-IO error kind like this. Because we renamed it for the new context. And this guy needs to be okay. We're chilling. Extract term info. This does not exist here, so that's fine. This is, we're gonna comment this out for a second. I'm not gonna worry about like constructing from recording. Maybe we'll just say unimplemented. And then comment out the rest. Set window size error, not found in scope. I see. So this is going to be, I guess for now, we'll just use box dyne stood error. And that will kind of just solve our problems magically, I think. This set window size is not defined anymore, so we need IO set self, IO set win size. Okay. And we don't pass in the FD anymore. Building a terminal or shell emulator. We're building a terminal emulator, not a shell. This guy again is complaining about unsize, so I'm just going to comment that out for a second. We'll come back to it. Write calls need to use the IO system now, so we're going to say written is equal to self IO write. And we don't pass in the file descriptor. We still pass in the content like this. Cool. And now this guy's returning a write error. I guess I'll come back to this. I might define error types here, I might not, but for now we'll just say boxstein stood std io error for now. For now, if you want to import error, refer to it directly. Okay, shut the fuck up. I don't care. Oh, that's actually coming up as an error? Why? How is it, like, that should be fine, shouldn't it? Not a trait. Oh. Oh, it's because stood IO error is the wrong thing. It's error. There we go. Okay. Let's keep going. These guys, this backtrace error thing, I'll come back to. No field file descriptor. So this guy is again. We replace the write call with the new API, which is self IO write to write. Boom, boom, boom. No field file descriptor on read. So again, we're replacing this with self IO read. Boom, boom. And now we are checking. Ooh, interesting. So here we're saying we might get an error that is, hey, the thing is empty. And before we were just kind of checking if Linux was telling us to call it again and otherwise logging an error. But we have to handle that case now. So this read guy must define maybe, let's see. How do we want to handle this? Do we want to define a like enum read result and he can say like empty or that there's more data or that we like read success data read. I hate saying read and read because like you can't distinguish between them on paper. So maybe we'll say like data, we'll just say success. I don't know. Yeah, sure. And calling this a result is kind of like fucked up. So like read response maybe is a little more clear because then there's failure and then successful. Like an empty is like a success case that's reasonable, not an error, so we can treat it as such. And then we can call this a read response like this. Okay, which means implementers of this guy must now return that thing. So read response, which means that we need to use read response. Okay, and down here we can say let res equal to this shit. Okay, and we can match res, right? And if it's okay v, we return okay read response success v. No e again says okay read response empty. Okay, and any other error goes to e. But we might need to box this guy like this. And what blah, 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 blah. Wow, I just like fucking like failed to talk at all. Holy shit. What were we doing before here? I think this is fine. Okay, so he expects PTY IO error kind. Oh, because this error was mapped. Oh, right. So this was a read error here, was what we were trying to say. But even then, I'm not really sure that makes sense because saying like failed to read file descriptor. Oh no, that seems reasonable. So why did we fail? Because we failed to read from the file descriptor. Okay, yeah, that seems reasonable. Which means that here we want to return an error that is what? PTY IR kind read on E. There we go. Okay. So now we have to say, when we read, match this. And if we get okay, read response empty. In this case, we break out of our loop. If we get okay, read response success, we propagate that thing and do the rest of the stuff. Okay. Otherwise, we got an error, and we should log that error like we do down here. And break. And so this no longer is a while loop. This is a just overall loop. Okay. And we forgot a bracket here and here. I think? No. Just on the second one. And then we delete this. Boom. And it looks like we compile now. Looks like we compile now. Sick. So what we want to do now is we want to cargo run, and we want to see, does everything still work with this like new interface stubbed out? Hopefully. So it looks like we're seeing a shell. It looks like we can change font size, and if we type, we're like wrapping correctly, and if we resize, the wrapping is still correct, which is good. And if we say like clear, bash is like doing stuff. So I think that like everything's there, right? That's 3 APIs, read, write, set window size, and they're all still like functioning, right? So I think there's nothing really to worry about too much there. We should probably do some sort of cleanup, so we can just start. Oh, we didn't ever fix this backtraced error thing, so I want to look at that. So, how do we do this? How do we do this? I guess we just uncomment this and we see what the fuck it's bitching about. So the size for values of type dyn stood error cannot be known as compile time. Sure. So what is the type of this? E is a box dyn error. Yep. And so I don't understand this backtraced error thing. He takes in an error as a reference. Okay. And so, like, what's the problem? Like, we don't need the size of something here. But I guess maybe this, like the type here, is saying we need this to be a thing. So we could maybe say this guy implements stood error. No, I'm not seeing it. The trait size is not implemented. The trait error is implemented for the box. Required for boxed thing to implement this thing. What if I put 2 ampersands here? No. No, no, no. We're gonna have to do some Googling. So, Rust take generic type by reference sized. Like, yeah, here we go. Why is size required to pass a reference to a generic type parameter? Most places where you see a type parameter, Rust will implicitly insert an additional plus size bound. However, your function's implementation is not required to be size, so adding question mark size effectively removes that implicit bound. So they're saying that in here I can say like this? No. He's saying colon question mark sized. So like this. And then this guy also needs it over here. So do I write like size like this? No. Consider borrowing the value. Okay. And now we're still not working. Oh, hold on. Okay, dereferencing it worked. We're close. Oh, we can't dereference it because we can't know at a compile time. God damn it. Okay, let's look at this again. So this guy, he makes a type that takes a reference to an error. Can we do like as ref error or something? And then do as ref or something? Missing lifetime specifier. So like this, put the A in here and put the A over here. And we need to say that this has a lifetime of A. Trait bound cannot be, we cannot use this as reference of that. Fuck off, E? God damn it. Oh, wait. Maybe this is fine. No. Fuck me. Fuck off. God damn it. Why is generics always make things so fucking hard, you know? You know? So let's just go back to where we were before. Comment everything out. Okay, so let's start by saying that this is unimplemented. And we'll solve the level 1 of error first, which is this. That we cannot call this function unless it's sized. And so we solved that by saying plus sized. No, we did not solve it that way. So we say take an E where E sized, E is error. Error plus sized. Like, what is it bitching about? The size values, blah, blah, blah. Oh, this is required for box to implement error. Hold on. Box, Rust. This might give us a clue. Box. So he's going to implement... Oh, god damn it. Let's read a little bit more detailed. The trait stood error is implemented for box T if it is sized. So can we look at that? Stood error. So this is implemented for box. Implementations. Trait implementations. Implementors, instant error, functions, traits, error. And, oh, here we go. Impl error for blah, 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 blah. Error for box T where T is error. Arc doesn't need the size. Thin box doesn't need size. What the fuck is a thin box? Nightly experimental API, okay. So maybe we can look up this thing for... Maybe we'll Google this. God, what a pain in my ass. This is wasting so much time. Why doesn't box.error error implement error? Rust tracking issue. Blah, blah, blah. Implicit size bound. Yep, like we saw already. If you try to apply this implementation, blah, 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 blah. Next step you take to fix this would be losing the bound to allow question mark size types, blah, blah. However, if you do this, blah, blah, blah. So are we just fucked? Yeah, it does seem like you're just fucked. That's cool. So we just can't use it this way? Oh my fucking god, dude, are you serious? Oh, what a fucking pain in my ass. Wait, but we got around this somehow before, didn't we? Maybe by putting like another ampersand here? No. By putting like a dereference here? Yeah, this worked. Okay. So now we have this and we do this. And we can just, what's it complaining about now? Cannot return value referencing parameter error because it's returns a value referencing data owned by the current function. Oh, because I put an ampersand here, so I just put this like this. Expected dyn error found error. The size of values for type error must be known at compile time. So can I say error as dyn error? Like this? Are you fucking kidding me? So I have to cast it again and then it's... How fucking stupid. How fucking stupid. So I guess here, instead of taking a dyn error, we can inject the type. And then formatted error will have to have another thing like this. Jesus Christ. So impl e through this, and then we say e cannot be known at compile time. Jesus Christ. Can I say... Oh my god. Oh my god. Why do I need the size of E? Oh my god, I'm gonna lose my mind. I'm gonna lose my mind. I'm gonna lose my mind. I think... This is such a simple thing, too. I guess... Fuck, man. All this is supposed to do is, like, display a backtrace of errors. Oh my fucking god, man. Okay, we'll come back to this. For now, we're just gonna return a string from this guy, and that will just make everything easier. That'll make everything easier. So we'll just take this implementation of writing the backtrace, and we'll say let ret is equal to string new, and we'll call ret f because we use it as f everywhere else, and then we say, okay, f, boom, boom, like this, and this guy's gonna return a string, and use stood IO right or something. Must implement IO right, stood format right, maybe? Question mark operator can only be used, so here we'll just say these are unfailable for now. Return string, return f here, and f down here. God damn it, damn it, damn it, damn it. Okay. So now we can delete this guy. There we go. That simplifies things for now. And we can go to all the places where we commented out backtraced error and put them back. Oh, what a pain in the ass. This is the type of shit that makes me worry about suggesting Rust to people, because what a pain, what a pain, what a pain. Alright, is that all of them? I think so. Looks like it. What else is it complaining about? This isn't using that, so we clean that up a little bit. From snapshot isn't used. Yeah, that's fine. From snapshot not used. Unused imports, unused imports. Okay. Sure. I think we got there. Git status. Git diff. Git add -u. Git add source. Terminal emulator IO. Git status. Git commit -m. Whip. Implement IO trait. I don't know. Fuck it. Okay. Next up. Implement the replay class. So, what's going to happen here? What's going to happen here? We're going to have, like, in source, terminal emulator, replay. Yeah, that seems like a good place for this to live. And we're going to go here, and we're going to say mod replay. And he'll say that he'll, like, replay. We have, like, replay state, I guess, is kind of like what this guy is. And what's he going to do? We need to, like, control. We need to, like, load a recording and return a IO implementation for playing the replay. And we're going to have controls for, like, moving the replay around. So we're going to have, like, you know, something like, I don't know yet. Maybe we'll go to the GUI and we'll see how we're going to use this guy. And maybe that will, like, clear things up for us. So where is our, like, GUI state? Here we go. So here we're going to have, like, a replay handle, replay control. And I guess that means that this guy's going to be called replay control. Which means that this guy needs to use terminal emulator replay control. Which means that terminal emulator needs to publicly use that guy. So we need to say pub use replay control. All right. And now we are going to have to, maybe he's not always going to be alive, right? It's only going to be if we're in a replay. Okay, which means that we need to take in a replay control here, which is going to be optional. Okay, which means in main, we're going to have to maybe construct this guy. So here we're going to say if we have a recording, we're going to construct a replay control. And we're going to say new from recording. And this guy is going to... That's fine. Yeah, we'll say replay controls this. And then maybe we'll even say we're going to have to, like, retrieve a snapshot from this guy. Initial term init is equal to replay control init initial state. So this is going to tell us where the terminal emulator gets its stuff from. Then the terminal emulator is going to use that init. Maybe we'll call it snapshot because that's reasonable. Get snapshot. Sure. Okay. Then in the then we need to return terminal emulator replay control, which means that this guy needs to be terminal emulator replay control, like this. Boom. And I guess we also need the IO handle here. So we'll say let IO handle is equal to replay control IO handle. Okay. So now this guy has everything he needs. He has, like, his ability to, like, get state from the replay and we have like our controller. And so then on this side, we're going to say that the replay control is none. And when we construct the GUI, we can say replay control like this. This guy needs to take in an option replay control. Boom, boom, boom. Everyone's happy. Then we can pass this on to replay control like this. Boom. Missing replay control. Okay. So here we just pass replay control on like this. We don't have replay control new, so we have to look for that implementation, which I think was in replay rs. Pub function new returns a replay control, and I don't know what that's going to do yet. All right. He needs pub function IO handle, which is going to return some sort of like impl of term IO. Yep. Okay. This guy takes, we're going to need to take in a recording here. Which I guess it looks like is probably a path here. All right. Okay. I guess this guy needs to know which implementation he is. So for now, we're just going to say box dyn term IO, but we'll come back to this and maybe make it like a concrete type. Doesn't really fucking matter. He needs to have this IO handle. Oh, he does, but I spelled it wrong. Handled should be handle. Okay. No method IO handle found on this in current scope. Why not? I don't know. Get snapshot. We'll come back. And this is going to return something, but we'll say it's unimplemented for now. No method IO handle found for this. Why? This guy returns a replay control. He has. Did I misspell it here too? No. IO handle. Oh, because I need self. I see. It told me the answer, and I just had to read it. Okay. Of course. Of course. Okay. Bing, bang, boom. One argument supplied here, two were provided. So we're going to have to fix this from recording thing, but he's going to take in an IO handle here, which is a box term IO. Dyn for now. And he doesn't take in a recording path anymore. He takes in a snapshot, which we don't actually have. We don't have a type for that yet. So maybe we'll just say we take in the recording still. And maybe we do something like let recording is equal to recording. How do we construct this guy? What did we do before? We said recording equals recording JSON from slice. Aha, aha. Yes, 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 yes. So maybe we'll deserialize it out here, put a fix me. Should not leak surdy JSON everywhere. But that's fine so far. And this can be recording like this. Cannot find type recording, so he needs to come from somewhere. This is in terminal emulator recording, and so we have to go to terminal emulator mod, propagate that thing. Pub use recording like this for now. And so then we can use recording here. But he doesn't like that for some reason. Because recording is private. Oh, because I probably imported it twice here. I did, okay. So we'll move it to the public section. Boom. Mismatch type, found path buff. Expected path buff found recording. So this guy's going to take in recording now. Use create terminal emulator recording. Okay. Expected recording found thing. So this doesn't come in like this. This just says recording like this. Maybe with an ampersand. Okay. If and else have incompatible types, do they? Why? because this is to say sum on it, of course. And borrowing moved value of recording. So for now, we'll just clone this, and we'll put a fix me stupid clone. But, you know, in prototype mode, I'm okay with taking whatever shortcuts I can. You know? Because I don't really care. We can sort out the details later. We're just trying to stub out what the fuck do our APIs look like. Okay, so now I have a way to like construct a replay control and inject them into the terminal emulator. This guy is going to have to do all of this stuff again. So he's going to get the stuff from the recording, all of the different snapshots, and then we're going to construct a terminal emulator out of that thing, but our IO is going to be term IO, or what do we call it here? IO handle. Boom. And then we can just return this guy. Cool. All right. And now we're chilling. Everything there just works. Terminal emulator is compiling. And so now what we have to do is we have to actually implement that shit. So you can go to replay and say, okay, now what the fuck is he going to do here? So we have like struct replay IO. Replay IO seems fine. Impl term IO for replay IO. Implement the missing members, boom. Bing, bang, boom. And so this guy's going to have to return some sort of handle here. But what's he going to do? Well, we're going to have to load the recording, and the recording is going to have like sequences of actions that he can do, right? So he's like recording, like what's in this guy? Items. And we have like an items iterator. Okay. So we can say like, recording, or maybe we'll store him. We'll just store the recording, the whole thing. And we're gonna have to keep track of like our current state. So where are we in the recording? And then probably like the total length. Probably. And somewhat, maybe for now, we'll just say next is the only API that we're going to support, just as like our sample. And so probably what's going to happen is replay IO is going to have like some sort of channel that he can read from. So we're going to have like use stood MPSC or sync MPSC self and receiver of U8 and sender of U8. I don't know if this is like a stupid way to do this instead of sending chunks at a time. But also, these guys' imports don't have types associated with them. That's stupid. And so he's going to be receiver. Maybe we'll make him receiver of vectors of U8, right? Of some like, yeah, chunks of shit. And this guy's going to have a sender. And when we increment the position, we're going to look through the current recording, figure out where we've sent, and send the next thing. Sure. But the sender... yeah, that's fine. Okay, so on read, we're getting like a buffer of stuff here. Actually, for now, I'm going to do... this is going to simplify stuff. We're going to send single bytes, and I don't know if that's like crazy inefficient. It probably is. But we can adjust later. Again, I just want to get like initial implementation going. Okay. So on this side of things, when we read from this guy, we're going to say self rx while let sum x is equal to some byte b for byte is equal to self rx try receive, and this is not sum, this is okay. We're going to increment the index. So we'll say let idx is equal to 0. This is mutable, and we're going to say buff idx is equal to b, and idx plus plus. Not plus plus. Plus equals 1 in this language. Okay, and then at the end, we're going to return okay idx. And this is going to be a read response success. Fuck. Language server crashed. So we'll go back here, and this is read response idx success. Response SE, not ES. And read response comes from here, I guess. Okay. What's he complaining about? Syntax error expected comma? Where? I don't... There is a comma. Oh, it was just behind. He was working too hard. You had to think. Writes we'll just discard. Right? In a recording, if somebody tries to write to the terminal, we just do fuck all. But I guess we return buff length to indicate that we succeeded. And set win size, again, we just do jack shit. Okay. Cool. Okay, so now we're gonna have to like figure out our position in this recording. And this is gonna be actually a little complex because we have like these like recording items that might be data write or like a set window size. Which means that like maybe we'll skip set window size for now, just to simplify things. But for now, we will start with only data. And we're gonna say like function extract len from recording. Actually, fuck it. We'll do everything. I think we can do it in one shot. So we'll say like recording len, and we'll take in a recording. Right? And we'll just say for item in recording items, let len is equal to 0. We'll return len, which means that this guy has to return a usize. Yep. And for each item, we're going to say match item. And we're going to say recording item. I'm scared to use that, so we'll just say a recording item here. Okay. And if we have recording item right, and we have some data, we will say len plus equals data len. Okay. And if we have recording item set window size, we don't really care about the context. We'll just say this is one thing that happened. Cool. So now we can say in new, we have let total length is equal to recording len recording. Okay. And then what's next? Current pause is 0. Recording is recording, and we'll say let txrx is equal to channel MPSC channel, like this. And I guess we'll have to store rx's in here as well. I guess maybe we have to store him as an option. No. We store the sender as an option. No. We store them both. Yes. Maybe. We'll think about this. So you have TX, RX, MPSC channel, and so you have replay, control, recording, current, pause, total, length, TX, RX. Okay. Bing, bang, boom. So we also need to say function recording index to action. And we're just going to take in the recording and usize, the index, and he's going to return a recording action, which doesn't exist yet. But this is either going to say write, and it's going to be a single byte, or it's going to say set win size, and he's going to have like width and height. Okay. Okay. I think it's coming together. So here, we're just going to do the same thing as this, but slightly differently. But we can start here. So we're going to iterate the items, and we're going to say let pause is equal to 0 for each item. We're going to increment pause, right? And then we're going to say let last candidate, let's think about this. We're going to say let item length is equal to this, which means that fix me factor out. Okay. And we're going to say if pause plus item len is greater than idx, we have the item. Else, continue. Okay. And then we're going to say pause plus equals item len, like this. Okay. Now, if this is the case, then we have the item. So we're going to say match item. And if it is a set window size width height, we say recording action set win size width and height. Okay. Boom. And if it's this, then we say we have a write of some byte of data at idx minus pause. Okay. Match item. This stuff has to get indented. We're missing a close brace here. And can we say width is star width and height is star height, I guess. Okay. This function expects a value to always be returned, but it might not. And so maybe we'll say none is another option here. And down here, we'll just say recording action none. Nothing to do in this case. Now, this is fucking stupid, right? Because we are recalculating. We are like re-looping through the whole recording for every byte. But that's okay. We can say fix me cache current item. Oh, and I was going to say we'll handle it later, but it seems so juicy to handle now. So we'll say struct recording tracker. And we'll say item pause z size. Right? And we'll say item idx, we would call it, and item pause. So we'll just comment this as like, which item are we iterating? And how deep in the item are we? And we'll say recording tracker get next item. I guess it's almost like an iterator for this guy. But we'll come back to that. Get next item. Right? And this is mute. And maybe we'll just call it next. And maybe we will just say impl iterator for recording tracker, because it feels very iterator-like. Type item is equal to recording action. So as we iterate this guy, we get more actions. Okay. Boom. And then we say we'll factor out this item length thing now. So we say function item length of item is a recording item like this, and we get a U size, and that's this code down here. Womp 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 womp. This guy gets copy pasted and indented and matched like this. Okay. This recording length thing now just says len plus equals item len item. Oopsies. Len. There we go. Okay. And so now we just say item len I guess this guy also needs to keep track of the recordings. So ugh, gross. This could like be like recording items like this, but that doesn't really work. So here's what we're gonna do. Instead of this guy implementing iterator, we're just gonna go back to impl recording iterator next, and he's just gonna take in the track that the recording is for at each item we place here. That way we don't have to worry with this like ownership bullshit. That like my Rust alarms were going off there, and so I'm just gonna do it this way. And this is gonna return a recording action. Okay, and so we're gonna say if item self item idx is greater than recording len of the recording, which is expensive. So we're gonna say total num. Oh no, that's fine. We don't have to do recording len here because we're in item. We have if item idx is greater than recording items len, we return recording action none. Nothing to do here. Then we say okay, so let item is equal to let's say let items is equal to recording dot items. Boom. Then we say this is items, and we say let item is equal to items at self item ex. Okay, and then we do the same thing. If what? Item pause is greater than item len item. We say self item idx plus equals 1, and we try again. Which means that all of this needs to be in a loop. Okay. This guy has to be like this. Okay. Otherwise, we have to increment item pause down here. But if we don't do that, then we can say let ret is equal to match item. And if it is, we've already done this. It's here. It's this guy here. It's just now pause is idx minus item pause here. Right. So does this make sense? This. Let's see. Okay. So here we have data, blah, blah, blah. So we take the data, we get the item pause. Here, if we increase the item index, we have to reset the item pause. Okay, because once we go to the next one, we're at pause position 0 again. Here it returns red, he increments item pause, and then returns red. All right. I think that's chilling. Okay. Which means that our replay control is going to have a recording tracker. And we're going to say let tracker is equal to recording tracker, and his initial state is he's at item pause 0, then item idx 0. Cool. Tracker. Boom. Okay, so now next becomes simple. It's let action is equal to tracker self tracker next, and we pass in the recording, and we can this needs to be mutable because it's going to adjust the tracker state. Okay, and we say match action, and we're going to say if it's a write, what's the type calling? Recording action. we're going to write the B to our handle. So tx write send B. I think that maybe the channel creation might return a result. No. So why is, oh, it's because we need self tx.send. This. For now, we'll unwrap that. If we get a set win size, for now, we're going to have to track that internally somehow. But for now, we'll say unimplemented. Because I don't know what I want to do here yet. And if we get recording action none, we do nothing. Simple. Simple, simple, simple. And now we just have to implement the IO handle. So we have replay IO. This is just box new replay IO. Rx is receiver self.rx. Which means that it's single receiver, multiple producer, which means that we can only create this guy once. So he's going to return an option. And we're going to say the Rx here is also an option. When he is constructed, it is present. But if not, we're going to say if let sum Rx is equal to self stood mem take Rx. So this is going to like consume it, replace the thing inside with none. And if we can, we are going to say, okay, sure, we'll make this thing. Sum box new. And else, I guess it's reasonable to panic here and complain at the developer and say, IO handle should only be called once. Fuck you if you call it twice. Use the question mark. Oh yeah, so it goes like this now. Okay. Okay. It's weird that this feels so finished. Well, okay, we're close. I guess now in the GUI code, we need to use the replay handle. So I guess for now, let's just say if maybe we'll make a panel here. So if we have replay control, we are going to create a panel. And I remember that there needs to be some sort of order to this thing. A panel covers the remainder of the screen, sure. So we'll just make a top panel, top bottom panel, top, tests, and we say show with the context, and we do some shit with the UI. And for now, we're just gonna say UI button next, and if it's clicked, if this guy is clicked, replay control next. Simple. Simple, simple, simple. And I guess this should, it doesn't really matter if it comes before or after this, but I guess before is slightly more correct. Slightly more correct. And I wonder if that just works. So we'll say, do we have a recording? We do. So let's just say cargo run recordings with 0JSON. Like, is this gonna work? No. Because this guy was an option, so main 76, this guy needs to be like unwrap. Oh, I guess this guy doesn't have to return an option because we're panicking in the case that he doesn't exist. Which means that this guy doesn't have to unwrap. Yep. Okay, we're close. So replay control is a at reference because we called as ref, so this just has to say as mute. Okay. And replay rs153. This guy needs to be mute. Which probably means in main we need to declare him as mutable. This. All right. Nothing's happening. CPU is railed in Termi. And so I guess something is infinite looping. So can we rust gdb target debug Termi, run it. Oopsies. Run with recordings 0JSON. Okay. Yes, restart from the beginning. And where the fuck are we getting stuck? Terminal emulator handle incoming data. Handle incoming data. So read. What the fuck? Something there is not working the way we expect. So let's just double check and one sec. Oh, recording tracker. Yeah, total length, that's fine. We get rid of this, And let's go into this guy. And so he says, while let OK be is try receive, and so we say here is how many things we returned. Oh. Probably this guy has to error out sometimes if idx is equal to 0. So this is okay, read response empty. Yeah. That's probably it. So let's see now if we still infinite loop on start. No, we're chilling. Okay. Oh, that's so sick. Holy shit. Wait, that's working. To some extent. Hold on. So the problem is the GUI... Hold on, let's look at this again. So the GUI is not like resizing itself to match the size of this guy. But overall, spamming the next button is doing something until it crashes. So we're gonna have to fix that. So this is at replay 85. So if item pause is greater than or equal to item length, item, we're off by 1 here. Hell yeah, baby. That's so sick. Okay, spam it again. Still crashing. Out of bounds on 75. Because again, greater than or equal to. Womp 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 womp. Okay. Spam, 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 spam. Sick. That's so sick. Okay. Okay. So now. Oh, this can go away. We don't need this. What is next? GUI size. Okay. So the GUI, he says, hey, I have like this amount of space to work with. Terminal emulator, could you please update whatever program is running and make sure that it knows how much space we have? And then he just assumes that succeeds. But in the case of a recording, we can't change the size because the recording was taken at a specific size. So it seems kind of reasonable for set window size to return an error in this case. So we could maybe say like pub enum set win size error, and we'll say unexpected maybe. There's like an unexpected error, which is a term IO error, right? But there's also like an expected error, which is like rejected or success. Yeah, sure. And so this guy is now going to return a set win size error, and implemented this guy, pty. He's going to have to say that we have return a set win size error. Okay, which means that he needs to import it from somewhere. Super set win size error. Okay. And this is going to be set win size error unexpected. Unexpected. Box new X. Like that? Something like that? Yeah, that's working. So we've got some like bullshit error manipulation going on here, which isn't great, but I'm okay with it for now. Okay. And then on our side of things, on the recording replay side, we'll just say this guy needs to take in, return a set win size error. And we're going to say set win size error rejected. Okay. Now the terminal emulator will try to set win size. And so in this case, he's going to say this seems reasonable. Fails to set window size, fails to set initial window size. That's like a pretty bad error. Trait std error is not implemented for set win size error, so we need to go back over there and implement it. Derive error and debug. And say this error is implementation does not support set win size. Okay, and error. Can we just say this is like transparent? No. We'll just say unexpected, unknown set win size error, which isn't really true. We might know what it is, but it's okay. He doesn't like this because we need to use this error like this, and maybe if that's imported, this transparent will work. Perfect. 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 Okay. Maybe this should return. It's pretty catastrophic if we don't know our terminal height and width. The buffer, like, we'll just have unexpected behavior. But now on set window size, we can say we try to set the window size. Oh, so we store the old size. Which I don't know if it's trivial to do that right now. So pub function get win size from the terminal buffer. He's going to return usize as self width and self height. Okay. We'll say let old width, old height. is equal to the terminal buffer get win size. If oh, hold on, we'll just put it in here. Pub old width. Yeah, like that. Pub old height, like this. Okay. Old width is self width. Old height is self height. Then we don't need this API. And we can say let old width is equal to self.width. Old height is equal to self.height. Which means that these guys don't need to be named like this. They can just go on and boom. Okay. So now when we set the window size, if it changed, we say, let's try to set this. So we'll say match this. And if it's okay, we do nothing. If it's an error, but the error is set win size error rejected, we undo the change in window size that we tried to make. So say response old width, response old height, and we need the self cursor state pause. We just undo it. But if it's anything else, we return an error. This. Okay. Oh, I guess we say unexpected. And that will make this work better. There we go. And this only gets logged if we succeeded, I guess. Sure. But this doesn't handle the fact that we need to know the window size from the recording. No, it does not, hey? So replay, the replay actually has to say what his win size is. Yes. Yep. And it's just gonna be self-recording. Gross. It's gonna be like self-recording, initial state, blah, blah, blah. So we're actually gonna not do this. I don't like this anymore. I don't like this at all. We're gonna set the window size and we're gonna get it after from the terminal emulator. And this is just we're going to add back that API that we didn't like a second ago. Which returns self width and self height. This, okay. This is gonna return self terminal buffer get win size, boom. Okay. And then in our GUI code, we are going to, instead of unconditionally setting the width and height like this, we're going to say get win size. Okay. That's looking good. Yep. Let width cars equal to width cars as F32. Height cars equal to height cars as F32. And so now this can like fail. And And we should see that like the frame is like fixed to the size of the recording. Which it is, kind of. There's something fucked up happening here. Let's see. What am I missing here? So we set the window size, we get the window size. Okay, so cargo run. Let's do it with no recording. Does this stuff still work? Frame, the red box is matching the size of the window, and wrapping is happening at approximately the right spot there. So I don't think we've kind of broken anything there. But on the recording path side, something's totally fucked here. The yellow is supposed to be like the scroll back, and the red is supposed to be like the frame. And it looks like the frame is just like consistently getting larger and larger and larger. Oh, and it's probably related to like the failure handling. Oh, yeah, so they try to set it and then they give up. Fuck me. Okay, let's back this up. Let's back this up. Instead of this like rejected concept, we are going to say it's invalid to call this unless it fails, or like unless you expect it to succeed. Okay. So let's undo all this shit. We'll keep the get win size, I guess. Maybe we won't even keep this. And the GUI needs to know that if we're in a replay, we can't do this. So if self replay control is, maybe we say let width cars and height cars is equal to some like match of self replay control as ref. Okay. And if it's some replay control, it's gonna say, hey, what's my win size? But if there's no replay control, then we say, hey, we're gonna set this thing and return what we thought it should be. Okay. Reasonable. And so now I have to implement this like get win size on replay control. Which for now we're just going to do as fix me better abstraction. I don't like this, but we're gonna say self recording get snapshot. Fuck me. Let terminal buffer is equal to self recording get snapshot terminal buffer. Oh, this is so ugly. And then we say what? Terminal buffer from snapshot like this, which is nasty. Nasty, 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 but we'll live with it. Terminal buffer get win size like this. Let width and height equals this. So this will be we get the initial from here. Height, U size. This is gross. Absolutely disgusting, but we'll live with it. Width, height. And then if we return width and height. Okay. If we get a set window size, we are going to have to handle that, but it's marked as unimplemented, so it's no big deal. We're just going to have to handle the one at the start. the initial state, use of undeclared terminal buffer. So I think here we can say terminal buffer. Hopefully this is sane. Perfect. And we need to implement get win size in the terminal buffer again, which is easy. Set win size, get win size, self. Gross, gross, gross. But we're in prototype mode. In prototype mode, we're allowed to make gross code, and we'll clean it up later. Self height, boom, boom, boom. Okay. Cargo check. Does everything come together here? Almost. Get win size, not on option replay control. So this is in a GUI 461. This just should say X. Maybe we can say this is replay control like this. We're close. Expected U size, found F32, F32. Right. So these guys have to say as, maybe this guy says let width height is equal to this, and we say width as F32, height as F32. Cool. Nope, still no? I thought we had it. Set win size error doesn't exist. Getters and setters galore. Yeah, not happy. Not that happy. For sure. So this guy goes back to the way he was before. I guess we can just hold undo on this and everything should just go back to the right spot. There. Unresolved import, that's fine. Get rid of it. Expected set win size error, so this is back to box term IO error. Which we have super IO like this for some reason, and this is just going to be, I don't know. For now, we'll just make this an empty error type. I don't really give a fuck. We can't do that. Struct derive error and debug for struct rejected set win size. Say error failed set win size not allowed. There we go. There we go. And then we can say error rejected set win size into. Boom. Really? Because we didn't use this error. Error. God damn. Okay. So now what I'm hoping to see is that the frame size matches what we expect. Oh, hell yeah. Hell yeah. That's feeling good. And so if I spam next now. Oh, fuck yes. Okay. So now we have to be careful. We have to make sure that what we're seeing replayed here is exactly the same as what we saw in our recording. So let's make a recording. Let's make a recording. I guess we've kind of done this and this. And so let's say git log. And we will start the recording and we will hit down, 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 down. Okay. So what we expect to see throughout this recording is like a scroll down from the rest into this commit, and then it should be broken at the end. Stop recording. And now we can cargo run with the recordings 1 JSON. Okay. And we can bring this guy up. And what we should say is like next, 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 next. So he scrolls, he types the rest, he scrolls again, he writes out this commit hash, and then he should overwrite some section. He goes down by 1, then goes up by 1. Oh, fuck yes. Okay. So that actually is like very, very revealing in and of itself. So we have this like recording of the issue, and we can see like very, very precisely what it's doing wrong. That's pretty sick. Pretty sick. I was kind of hoping to get some sort of like timeline scrubbing going in, as well as like I wanted like visualization of like which characters we're displaying. But we're at the 1 hour 50 mark, and I don't think I'm going to get either of those done in the next 10 minutes. But that's like super sick. Look at that. That's so cool. So here we see debug render. Everything's chilling. And yeah, we can just spam this and see. So I think that's pretty good progress for the day. Pretty good progress. Thanks for watching, guys. If you liked what you saw, I stream most days at around 1 or 2 o'clock Pacific time for 1 or 2 hours. Right now we're working on this terminal emulator, but we cover a variety of topics here. Like we've done like some 3D graphics, we've done some AI, we've done some operating systems, blah blah blah. So it's kind of just like whatever we feel like, or whatever I feel like is what gets implemented. So if you like that, feel free to hit follow. If you're watching on Twitch, there's a YouTube link in the Twitch description, which where all the VODs go up into like playlists by project. So if you want to go see what else we've worked on or catch up on stuff, that's all there. There's a GitHub link in the Twitch description as well, where polished up versions of the code that's on stream end up. So you can see like for Termi, we've got actually maybe it's better if I git log this. We have like pretty strong commit messages with like that are broken up into like bite-sized chunks. So if you want to like take a look and see how anything's implemented, that's all there. Yeah, if you're watching on YouTube, there's a Twitch link in the YouTube description. You should swing by, say hi. And otherwise, thanks for watching, guys. Catch you on the next one. Bye.